Thanks everyone for joining us here. We dedicated this month to open technologies for power. We intended to cover 3 of the latest announcements: Open Power Foundation, POWER8 processors, and Canonical announcement of its latest Ubuntu 14.04 LTS. In our last call this month, we had great insights on Open Power Foundation and POWER8 processors. And today, we have Ubuntu on POWER8 by Canonical itself. Ubuntu is fastest Linux-based operating system. It's fast, it's safe, and it's open. It runs on desktops, servers, and in the cloud. Ubuntu is supported by Canonical. They are the providers of expert services, specialist tools, and consulting services. I'm glad that today we have a team of Canonical with us on our Linux Ambassador call. I'm also delighted to welcome Dan Pollard, who is a lead solution architect for cloud, channel, and partners at Canonical. He has more than 15 years of experience working and consulting on Linux for the enterprise and for service providers. We have Bill Buros, Senior Architect, IBM Linux Technology Center, also with him. Today, they'll be sharing a live demo on Ubuntu on POWER8 platform. Before I hand it over to Dan and Bill, just for the information for the link to the live demo, you can either refer my mail shared this morning or our Linux Ambassadors Wiki. So over to you, Dan and Bill.
Thank you very much for that introduction, Seth. I'm very pleased to be here. Thank you for the opportunity. The purpose of this session is to share some understanding of where Canonical and where Ubuntu come from and kind of tell the story that's behind Ubuntu. We'll talk about the collaboration between IBM and Canonical as related to Ubuntu 14.04 LTS on the POWER8 platform. And we'll go over some vocabulary, words like what LTS means, some of our tools like MAAS and Juju. We're also going to share a demo of the capabilities of our tools. Now, everything that I am going to show today, along with Bill, is real. These are completely live demos unless we state otherwise. We'll show a demo of some of our tooling and some of our capabilities using virtual machines on x86. We'll be showing a demo on POWER8. We're going to deploy several applications, including WebSphere, in the space of just a few minutes. And finally, we'll demonstrate a virtual web-based environment that you can go play around with yourself to gain some experience and some understanding around the tools. I'm going to repeat the demo link just in case anybody missed it. The link is very easy. It's ubuntudemo.com/DAP. DAP. Again, ubuntudemo.com/DAP. All right, so moving right along. Put very simply, Canonical is the company behind Ubuntu. We are the commercial entity that, along with our partners in the community, develops and provides the Ubuntu platform. We're not new, per se. We've been around since 2004. Lots of folks we discover have heard of Ubuntu, but have never heard of Canonical. So you may be surprised to know that we've been in business for 10 years. We have, as of this morning, I believe 648 employees in 30 countries. We're headquartered in London. Our U.S. office is based in the Boston area, and we have a significant presence in Asia Pacific as well, in Japan, Taiwan, and mainland China. So what exactly is Ubuntu? Ubuntu is the 3 orange circles you see here. It's the OS, the Linux-based OS. It's tooling around that OS and even beyond that OS through some offerings called Juju, MAAS, and Landscape. We're going to talk in detail today about Juju and MAAS. And then finally, we provide an OpenStack platform as well. Canonical provides services around these 3 orange circles, if you will. We've offered these services, professional services and support as well as engineering services on x86 for the 10 years we've been in business, and now we're bringing that to the Power platform as well. And Bill, I don't know if you wanted to jump in here and add anything relative to the relationship between IBM and Canonical.
One of the key parts, Dan, as you know, is that we are building our new POWER8 boxes around the cloud, around the scale-out offerings. And so you will observe that the newest POWER8 systems that were announced are, they're scale-out, they're designed for cloud, they're designed for data manipulation, and all three aspects that Dan's highlighting here, the Ubuntu server OS, working in the cloud and working with OpenStack, IBM and the Linux Technology Center and Open Power are all collaborating around this front. So this is what's exciting about this realm. It's a brand new opportunity, and we think the combination of all the pieces are going to be pretty dramatic and pretty real.
Yep, thanks, Bill. So one of the fundamental differences we like to kind of underscore when we talk about Canonical and about Ubuntu is the fact that we Canonical have a fundamentally different conversation with our customers. You can go to Ubuntu.com, you can download the OS, you can download the tools, you can play with them on your laptop, you can do so with no limitation or difference relative to what you would find in the POWER8 platform, in the server platform on x86, so on and so forth. Whereas other free Linuxes, Debian, OpenSUSE, Fedora, do not carry support. They're freely available, but they are not supported. Then you have SUSE and Red Hat, where every system on which you run the bits must be under a support entitlement. We're different because we permit the customer to make the choice. And the model that we typically see is exactly what I just described. Support may be on, for example, the system in production, the POWER8 environment, if you will, but this enables developers to download and develop in the exact same environment on their laptop, the only difference being just x86 versus Power, and we'll talk about why that's not as big of a challenge as it has been in the past. So Ubuntu is the go-to choice for web and cloud because it's designed for enormous scalability and scale out rather than scale up. Where we see the most use is in applications that do scale out, particularly on a very massive basis, huge clusters. As an example, I'm currently talking with a customer who's running a 256-node Hadoop cluster on Ubuntu. They're looking at going to 4,000 nodes and beyond. We recently did a test deployment on OpenStack of 168,000 virtual machines running on Ubuntu OpenStack on 500 hosts. That's the kind of scalability that we're talking about. The charts here are a little bit hard to see, I realize, but these are talking about the role that we play in the public cloud as well as in private clouds that we survey. What we know is that more Ubuntu is run than all other operating systems combined. And so as an example, when you look at DigitalOcean down at the lower left here, which is a very popular public cloud provider, we are fully 2/3 of the workloads running in the public cloud there. Bear with me here. The slides are just a little bit slow to change, I realize. So who runs Ubuntu? We tend to see Ubuntu used in companies like us that have been around, like Canonical, that have been around since the mid-2000s. The somewhat overused and tired term is born-on-the-web companies, companies where development cycles are rapid, applications are purpose-designed for the type of scalability that Ubuntu provides, that scale-out kind of flexibility. And so you can get a sense here from this slide, some of the major corporations that are working with Ubuntu. Just because we're popular in these born-on-the-web companies does not mean that we don't also play a role within the enterprise and within the service provider space as well. In addition to being the choice operating system to run Ubuntu within the cloud, Ubuntu's OpenStack is similarly the choice platform on which to build a private cloud. Just as more Ubuntu is run within public clouds than all other choices combined, more Ubuntu OpenStack runs the private clouds than all other choices combined. Where we're seeing that significant adoption is in large enterprise and telco. So we've established kind of who uses Ubuntu. Let's talk a little bit about why they use Ubuntu, and we'll talk a little bit as well about why this is important to IBM as well in the PowerPC space. This slide has a lot to do with why people use Ubuntu. This shows our pace of development. Every 2 years, we have a release that is called an LTS release. LTS stands for long-term support. An LTS release is under support for a period of 5 years. We're very excited because if you look at the numbers here, Ubuntu 14.04, that's year.month. So April 2014, we just in the last few weeks had an LTS release, which will be supported for 5 years. In between those LTS releases, so our prior one was 12.04, our next one will be 16.04. In between those LTS releases, every 6 months we make what's called an intermediate release. And those intermediate releases, the naming follows the same convention here. So 12.10, 2012, October was 12.10, so on and so forth. We do this every 6 months. Those intermediate releases are supported for a period of 9 months. You can just about set your watch to when releases will ship. They are not late. We target dates. We hit dates. This model enables continuous innovation and flexibility. Customers can find long-term support and stability on LTS releases when they need it. They can still go cutting edge, get the latest features and functionality, and be supported in doing so for a period of time on those intermediate releases. The other interesting thing about this, too, is users can upgrade from one intermediate release to the next. So we're not asking our users, particularly our enterprise users, to burn down their environment and to completely rebuild it from scratch every 6 months. One command will upgrade an environment to the next intermediate release.
One of the key things for this, which we need to understand, is this is a game changer in the context of how we can release function and features for the POWER8 base. As the POWER8 base was announced, there was numerous references to new technologies which are emerging. There is CAPI enabling coming. There's new adapters coming. There's NVIDIA is working. And so there's a number of areas where we want to introduce fully supported, fully customer-supported environments for some of these technologies. As we look at Ubuntu's and Canonical's standard releases, those standard releases provide us the perfect vehicle for introducing new technologies on a fairly fast pace while targeting in a longer-term goal of integrating these into a long-term support model. So I think you're going to see some very interesting things as we roll over the upcoming Ubuntu releases, the standard releases, and then we all have an eye towards the next long-term support model, which is coming later. So that's one of the key places where we see a nice intersection of Canonical and the IBM POWER8 efforts.
And Bill, I don't know if you want to say anything else here on this slide as well, but from my perspective, oops, where'd my slide go?
Yeah, and it's the same thing, Dan. Like you said, that this is where the real collaboration comes into play. Our systems are designed for big data. We actually have designed them specifically for the cloud. And as I mentioned before, the CAPI, the I/O, the SRIOV pieces, all these things coming together with KVM and Ubuntu are going to be an interesting play, a very exciting and interesting play.
And one of the things, let's pause also and sort of mention here why, at least from my perspective, from the Canonical perspective, why we are so enthused about the POWER8 platform. And the thing that's particularly interesting to us is little endian mode. Because in the past, Power has been a big endian platform. Packages needed to be particularly designed to handle the data ordering properly on big endian as well as on a little endian platform like x86. With a little endian mode, that limitation, that restriction, and that need to be particularly sensitive to data ordering goes away. Source packages that build on Ubuntu for x86 will build without modification on POWER8 in little endian mode. To underscore this point, if you look at kind of what we're saying here, you might be thinking, okay, 650 employees in business for 10 years, how do these guys ship a software release every 6 months? And the answer to that is we are highly, highly automated in how we build and test software. To underscore that point, when I say we are highly automated, when we started to work on the little endian POWER8 platform, we of course had to rebuild all of our source packages for POWER8 little endian. We did so in the space of 5 months, and that's 40,000 software packages that comprise Ubuntu rebuilt in the space of 5 months for POWER8. So let's get a little bit specific now and talk about a couple of our tools in more detail. The first tool we're going to talk about is called MAAS. MAAS stands for Metal as a Service. What MAAS does at the most basic description, MAAS gives me an API that I can use to talk to bare metal and to control it, bare metal servers. This means that it gives me an interface through which I can control hardware. I can learn about what's in the hardware, and I can use MAAS to get Ubuntu installed on the hardware. I can do this directly through a web GUI. I can use a higher-level tool like Juju, which we'll talk about in just a second here, to control MAAS to install software on the system. Because I'm doing hardware discovery through MAAS, it lets me make smart decisions about my hardware. For example, I can leverage the API to say things like, deploy a new system, but only deploy me a system that has a POWER8 CPU, or only deploy me a system for a database that is a POWER8 CPU with at least 16 gig of memory, things of that nature. You're probably wondering how this works. MAAS is responsible for protocols like PXE and DHCP. So when a new system is powered on in the data center, it can then be quote-unquote seen through MAAS. MAAS will boot it with an image that's capable of running some discovery and communicating back to the MAAS server what's in that server. We go through a process called enlistment and commissioning, which then makes that server available for general use. I understand what's in it, and then I let it be there to be called by a higher level system for provisioning. So, mentioned Juju a moment ago. Juju is that higher level service orchestration tool. It leverages MAAS, among other services, to deploy and scale workloads to that massive horizontal scale that we discussed before. Juju uses a unit called a charm, and a charm is what describes a particular piece of software and how to not only install that software, but how to respond to certain changes in the environment. Not just how do I install, but how do I scale up? How do I scale down? How do I connect to another piece of software? Things of that nature. And what we're actually going to do here is I'm going to switch screens, and I'm going to, we're going to start a little demo here. And like I mentioned a moment ago as we started, everything that you see in this demo is live. So we'll have a couple of pauses here, but we're going to show you 3 different environments as we go through this. So the first environment I'm going to show you is actually hosted locally on my laptop. If you can see my web browser, and if there's any issue in display, somebody on the speaker line, please let me know. I have web interfaces here for Juju and MAAS. My environment here is not provisioning bare metal. What I'm actually doing is I'm using virtual machines through KVM just locally on my laptop. And so you can see here through my virtual machine manager, I have Juju and MAAS running, and I have 8 nodes that I can provision here. Now, to be fair, this is a laptop-based demo. These nodes have about, I believe, 1 gig of RAM apiece, so we can't deploy anything highly complex. But what I can do here is real quick, I'm just going to go to my node 2, and I'm just going to say, start node 2. And I'm using MAAS to do this, and we can see node 2 just popped on here. And here's his console. And we'll sit here for a second. We're going to see him boot up. And in the space of about 20 seconds from now, what we will see is a series of dots start to scroll across the screen. And those series of dots are actually an image of the operating system being written out to the disk. So let's see how long this takes here for me to install an operating system. And we're still just booting up here. And here come my dots. And so here in the space of, we'll get an accurate count as we finish here, but in the space of just about probably a minute and a half, I will have installed the operating system. 47 seconds. There you go. And so now this node will reboot and come up with the operating system, and life is grand. So what I'll do here is I'm actually going to turn him back off. And we'll use Juju to do some deployments here. And I'll leave this open here so you can see nodes start to pop on as we deploy with Juju. So what we're looking at now is called Juju Canvas. And this is the GUI. Anything that I do here, I can do through an API as well. This is actually, in fact, just an instantiation of the API. So let's deploy a simple application here. I'm going to deploy MySQL, and I'm going to do that on the left here. This is what's called the charm store, and we'll talk more about that in just a second. But I'm going to deploy a simple application like MySQL. And when I pull that charm out and I put it on my canvas, I'm asked if I want to set some basic settings. If I want to ask MAAS for a machine with certain characteristics or certain power, I can do that here, or certain architecture. For example, I could say I want a machine that's power 64, or power 8, excuse me. I don't want to set any of those things. I just want to pick any available machine. And we go forth and deploy. He gets a yellow bar. That means that he's coming up. We'll see that bar go green in a minute here. And while we're doing this, I am going to also deploy MediaWiki, which MediaWiki, if you're not familiar, is the software that runs Wikipedia. And while we're doing this here, you can see that my node 5 just turned on and was picked for that MySQL server. As I pull my MediaWiki charm out here, and I'll do the same thing again. I'll say deploy. Oops. My web interface is just a little touch slow here. And so node 8 just turned on and was picked for MediaWiki. So while these are coming up, I'm also going to do what's called building a relationship between them. And what that does is that tells MediaWiki, how do I use MySQL? How do I relate to MySQL? What's the point of us being here on the same canvas? And the relation that we're building is going to say, use MySQL as your database for data that's put into MediaWiki. I'm also going to deploy an application here called HA Proxy. And HA Proxy is exactly what it sounds like. It's a highly available reverse proxy that can sit in front of a web service like MediaWiki. And the reason why I want to deploy HA Proxy I'm going to pull him out here, click deploy, and I'm going to try and build that relation here as well. And notice what happens. As soon as I click build relation, MySQL grayed out down here. And that's because HA proxy understands that its relations only relate to things that offer web services. It does not know how to relate to a database like MySQL. There we go. And so when that happens, there's no logical reason that HA proxy would connect to MySQL, and so MySQL grays itself out. So I connect them to MediaWiki. We'll kind of wait a minute here for these to come up. It won't take very long. Let me kind of switch gears here for a second and talk about what I actually just deployed. So I mentioned that this is called the charm store. We have these things called charms. What are charms? Charms are essentially a description of the best practices of how to install that software, whatever that software happens to be. So let me take, for example, the MySQL charm. And by the way, we can see he's gone green. He's come up. He's running. You can see I deployed 3 charms here. I have 3 virtual machines. 3, 5, and 8 were selected and are up and running. So let me pull open the charm details. Every charm comes with a basic description of what it does. It describes how it can be used, and it describes various configuration variables that can be set at the time of deploy. The reason that we do this is, for example, in an application like MySQL, there may be hundreds of configuration variables that are accessible that might need to be changed. Maybe a developer only changes 10 of them when they install the application. We can expose those 10 to configuration during the course of installation, so that they can be set and changed right as the charm is deployed. So if the charm is the best practices of how an application is deployed, how do we actually do that? Let's look at the code. So in any charm, the code of what makes up that charm can be viewed right from the web browser. You can download it, you can pull it apart, you can reconfigure it, you can apply it to a different application, all of those sorts of things. A charm consists of 4 files, 2 of which are just flat text, a revision number and a README file. The other 2 are YAML, which is a very simple and easy to digest language that describes the structure of the charm. The remainder of the charm are a series of what are called hooks. And hooks are essentially the description of what I'm supposed to do as that application when I'm asked to do certain things, when I'm asked to scale up or scale down, when I'm asked to create a slave instance of a MySQL database. What are the things that need to be done during the course of those activities happening? The interesting things about hooks are I'm not asking anyone to learn a language that they don't already know. Hooks can be written in any scripting language that can be interpreted in Linux. So if a developer is most comfortable writing in Python, that's great. They can go write in Python. If the developer is most comfortable writing in Bash, fantastic. They can go write in Bash. The other interesting thing about a charm, you may have noticed here, I haven't said anything about where the software actually is coming from. And that's completely intentional. I can encapsulate the software, the binary packages in the charm, but I don't have to. And this enables a couple of interesting things. So for example, if I'm running in Juju on POWER8, my charm may just say, go out and get the software, and the platform will make the decision about what binary package to pull down, x86 versus POWER8. I'm not dictating that. I'm not wrapping in the charm, and therefore I'm creating platform-independent charms. I'm not stating that, oh, this charm is only going to work on POWER8, or this charm is only going to work in this particular public cloud provider. And yes, by the way, charms can be used to deploy to public clouds as well. So the cool thing here is whatever stuff has to happen behind the scenes to get the software is not affected by the charm. As long as we can script it, we're perfectly happy and content to go get the software. That includes licensing of a commercial application. So if something has to happen behind the scenes not only to get the software, but to license it, to consume a license on that node, that's perfectly fine. As long as we can script that process, we can wrap it into the charm. Unfortunately, it looks like, as sometimes happens here in live demos, my MediaWiki instance did not come up, so I'm not able to show logging into MediaWiki, but I will show our POWER8 environment. And so I just switched tabs here, and now I'm in a POWER8 environment that's hosted in our lab in Boston. And you may notice that this looks exactly the same as the x86 environment I was just in. And that's exactly the point. As we talked through how everything builds natively on POWER8 as it does on x86, everything looks the same and works the same. And actually, I'm logged into the system via SSH here. And versus dragging and dropping things out here in this particular demo, I'm just going to run a script to do my deployment here. And we'll see the script is going to pull a bunch of charms in. And as I run that script again, it's just manipulating the API. We can see a bunch of applications deploy here. This deployment takes about 3 minutes. And this deployment shows 3 distinct applications being deployed on POWER8. This over here is Sugar CRM, which is a popular CRM tool. And you can see how quickly bars are going green. That's how quickly we're able to deploy onto POWER8 here using Linux containers. We're also deploying WebSphere using the Liberty profile. I was at Impact a few weeks ago in Las Vegas, and I would ask customers coming up to our booth, so how quickly do you typically deploy WebSphere? And you get answers half a day, 2 days, something like that. In this case, we're deploying WebSphere in the space of about 3 minutes. So it's definitely a differentiator when we look at how to deploy these tools. But the cool thing is, one of the very first things we did with Juju up and running was we went and wrapped WebSphere in a charm. We rapidly described it in that format so that it could be very rapidly deployed with Juju. So while this was deploying, we'll come back to this in just 1 second. The final thing that I'm going to show you today is an environment where you can go play around with this yourself. And that environment, that link is jujucharms.com. And Juju Charms is a Juju canvas with no back end. We're not actually deploying machines here, but I can just play around and I can go forth and build an environment and just kind of get the sense of how Juju works. And you can see when I deploy something like MySQL, it instantly goes green because I'm not actually deploying anything. Let me reset my canvas here. The other thing that you can deploy using Juju is what are called bundles. And bundles are charms that are already interrelated, interconnected, where I can deploy an entire environment in just one operation. Let me give you an example of what I mean by that. I can take a very complex application like OpenStack, which has all sorts of components and dependencies and interrelations, and I can drag that out onto my canvas in a real environment. I can deploy OpenStack in the space of about 20 minutes with all of those interdependencies already built. One of the things we haven't touched upon is that scalability factor. We've talked about POWER8 being a great platform for scale out. We've talked about Juju being a great orchestration tool to enable that scale out. What do we mean by that, though? Let me show you what we mean by that. So if I have my OpenStack environment here, and I take Nova, my compute nodes running Nova, and I click on that, you'll notice here I show 1 of 1 unit up here in my details about that Nova compute node. Were this a real environment, if I needed to scale my Nova, I could simply do that. And I'd just be offered the opportunity to confirm that, and a second node would go out, be deployed, and hooks would be run within the charm to perform that deployment and have that charm come up live, have that additional node come up and be connected into the cluster. Nothing, as long as I have the underlying hardware in the environment, stops me from taking 2 to 20 to 200 to 2,000 in a single operation. And so remembering that this is all API-driven, I can very rapidly develop something against that API to start to identify constraints. When my application hits certain characteristics of load, that's when I know I need to add another unit, go forth and do so automatically, join him to the cluster. Existing nodes are not affected by this join operation. We're not taking anything out of service to join an additional node to a cluster, to an environment. Of course, we're not performing magic here. We can't take an application that does not understand scale out or clustering and make it magically understand it, but we can take these web-style environments, if you will, these things like OpenStack, these things like Hadoop, and very rapidly scale them in a repeatable fashion. One other thing that I'll show you here in the Juju Charms environment, just to give you an example of how complex we can make charms. One of our sales engineers actually wrote a charm called Complex Web App specifically to demonstrate the level of complexity that we can get to with these bundles. This bundle represents 27 different services running across 37 different machines, just to give you an idea of what that would look like. So it's very easy to create kind of crazy architectures here and deploy them repeatedly, consistently. This also enables a developer to work locally on their laptop, build charms, build these bundles, and then deploy them to POWER8 without modification. So I can see here, back to my POWER8 demo, in just over 3 minutes, I've completely deployed my bundle. I have running applications. Everything is green. We're running a little bit short on time here. I won't go through the whole thing because I do want to make sure we have time for questions. But I will, in the case of WebSphere, go log into that unit. So I can see my WebSphere Liberty IP address is 10.0.3.1.48. He's running on ports 9080 and 9443. Let me go to that link. There's my WebSphere. Visit Pet Store. And we have the demo Pet Store application running here as well. Okay, so this ends the speaking session of the presentation, or portion of the presentation. Bill, do you have anything that you want to add before we open up for questions?
No, Dan, I do not at this point. You covered that very nicely.